Good morning, everyone. So today I would like to discuss about my research proposal about the analysis of the effect of incorporating animal bone as a partial cement substitutions in the concrete productions. Then let's start with the research background. The first is the environmental issues from the bone waste of 107.26 tons over years. The second is the high carbon dioxide emissions from the Portland cements, which taking account of 8% globally. The third is the potential utilizations of animal bone as an eco-friendly material with supporting the waste management. Then the problem statement is consisting of the first is ineffective bone waste management and high carbon footprint emissions from the cement productions. And then the second is lack of the research in assessing the influence of animal bone as to the mechanical strength as well as durability performance of the concrete. Then the research objective at the first is to obtaining the measurable mechanical strength of animal bone as blended concrete with consisting of compressive strength, flexural, and split tensile strengths under various substitutions levels. And the second is to obtain the measurable indicators of concrete durability through the water absorption test and chloride ion penetration test under various substitutions levels. The third is to determine the animal bone acidification level, and the fourth is to evaluate the feasibility of animal bone as blended concrete for structural or non-structural use. For the scope of the result, it's focused on the bovine bones as only, while the testing is confined at the laboratory scale, for the substitutions level is ranging from the 0% to 5%, for the mixed design will following the SNI 7656 of 2012. Then is for the literature review. For the theoretical background is the concrete is a composite materials which consisting of cement, water, coarse aggregate, and fine aggregate in which its strength development is realized on the hydration reactions. The strength development depends on the hydration of reactions where the calcium oxides and 3 calcium silicates react with the water to form a calcium silicate hydrates as a compounds that responsible for the concrete strength. During the hydration reactions, calcium oxide plays an important role, particularly affecting the early strength development as well as accelerating the setting time. Animal bone as which derived from the calcites, animal bone has high calcium oxide content of 42.87% to 68.34%, which is comparable to the limestone which used in common cement productions. Then this is the several previous research about the incorporation of animal bone as the first is the research by Hawas et al. In which they use the animal bone powder with optimum dosage of 10%. As a findings, they find the strength is decreased with the doses, while the 10% exceeds the control compressive strength. Second is the Ketahun and Beckett in 2021, which they used the kettle bone as at 5% substitutions levels. They find that the bone S has the high calcium oxide content with 5% substitutions can reach 34.94 MPa, while the higher dosage can decrease its strength. The third is by Musa et al. At 2022, in which they use the animal bone S with the optimum substitutions level of 5%. It is suitable for node applications with the substitutions levels higher than 10% is not viable structurally. The fourth is Luca et al. In 2019, which they use the combinations of animal bone ash and metakaolin with the optimum dosage of 22.5%, which the animal bone ash act like as a fillers in which 32.27 MPa at 28 days can be achieved, and it also improves the concrete durability. The fourth is the Palomino et al. In 2025, in which they use the combinations of pig and bone powder with the substitution level and optimum is 10%. As a finding, with the 10% of substitutions, it can reach the control strength which is suitable structurally. The five is the by Abdul Wahab et al. In 2025, in which they use the co-bone S at 5% substitution levels. They find that the bone S has a comparable CaO contents to the limestone, with 5% substitutions can achieve 25.9 MPa as the highest compressive strength, and it has the best water resistance. And for the methodology are an ordinary Portland cement type 1 is used as the primary binder. The tap water which will be used for mixing and curing must be clean and not containing any organic contaminants and sludge. For the coarse and fine aggregates are procured from the local suppliers, in which will be cleaned first prior to use. For the mix designs will follow the SNI 7656 of 2012 with a desired compressive strength of 30 MPa after 28 days of curing and consistent water-cement ratio. Animal bone ash are obtained from the calcining animal bone ash, particularly bovines at 1000 degrees for the 10th hour. The animal bone ash must be undergone XRF investigations prior to use to ensure it has the comparable CaO content to the limestone. The ash will be substituted by the varying dosage of 0, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, and 5% by its means. Prior to the casting, the concrete will be tested using the slump test to ensure it has the better performance on the workability. And then for the specimen itself, it has the 550 times 300 for both compressive and split tensile strength test. For the beam, 100 times 100 times 500 for the flexural strength test. For the cube is 500 times 500 is used for water absorptions and chloride penetration tests. For the testing and for the slump test, I refer to the SNI 1972 of 2008. It will be used to measure the workability and consistency of the fresh concrete. It helps to observe the water demand change due to animal bone ash substitutions. For the compressive strength, I refer to SNI 1974 of 2011. It evaluate the resistance to the axial loading of the concrete is conducted after 7, 14, 28, and 56 days of curing. A split tensile strength test I refer to SNI 491 of 2014. It assessed the concrete tensile resistance through indirect loading. It used the cylindrical specimen loaded diametrically, conducted at 7, 14, 28, and 56 days after curing. For the flexural stance is referred from HTMC 78. It measures the modulus rupture using the beam specimen under third point of loading. It also indicates the resistance to the bending as well as the cracking. For the water absorption test, we refer to ASTM C642, which is quantifies the porosity and the permeability, with the lower values as a better durability and the compactness. The concrete chloride ion penetration test, I refer to ASTM C1202, which measures resistance to the concrete chloride ingress and indicates concrete suitability for environments prone to the corrosion, especially in marine environments. For the data analysis techniques is involving the first is descriptive statistical analysis, which is calculate the mean, standard deviations, and coefficients of variations of the test result. It assesses the data consistency and reliability across the specimens and ages. For the comparative analysis is used to compare its animal bone S to the control mix, which is 0% of animal bone S, which PI higher than 500 indicates a better improvement on the performance. If PI equals to 100 indicates equal performance to the control mix. If PI less than 100 is indicates the reduced performance compared to the control mix. And then for the trend and regression analysis is used to model the relationship between APA content and the compressive strength, tensile strength, and flexural strength, water absorption, and chloride penetration parameter from the test of the concrete. Then for optimum API substitution levels is determined based on the minimum 30 MPa compressive strength, improve or acceptable workability and durability. It indicates whether the mix is suitable for structural or non-structural applications. And the following is my research flowchart diagram. It started from the problem identifications, literature review, formulations of research objective, and then determination of methodology. After that is the material preparations. In the material preparation, it involves the bone as characterizations of RF testing of CIF content. If it's comparable, we can continue to the mix design and slump test. After that is the specimen casting, alternate curing, and then the testing of specimens which involve the compressive strength test, split tensile strength test, flexural strength test, water absorption test, chloride ion penetration test. After that, it will undergo the data analysis involving descriptive statistical analysis. Second is comparative analysis, trend and regression analysis. The last is determinations of an optimum APA substitution levels. After the series of the data analysis, we will conduct the result interpretation and discussions. And after that is the conclusions. And that is all my presentations, and thank you for your attention.